According to critics of Darwin's theory, the problems facing macroevolution can be clearly seen in yet a third icon of evolution, the four-winged fruit fly.
In opening a biology text, one will often see a picture of a four-winged fruit fly. Now, as we know, ordinary fruit flies have only two wings. The four-winged fruit fly has not only its regular set of wings, but a second set of wings just next to that. And the caption or the text will say, this is evidence for the process of evolution, that mutations affect the process of development, and you can get anomalies as interesting as a four-winged fruit fly. Well, it turns out that the four-winged fruit fly is actually a very poor example of Darwinian evolution, certainly.
There are no muscles attached to it, so the second set of wings is effectively dead. The fly is a hopeless cripple. It's kind of like having a small plane with an extra pair of wings tied to its tail. The fly can only survive in the laboratory, and it would be selected out by natural selection in the wild. So it's not a step forward in evolution. It's an evolutionary dead end.
Modern Darwinian theory, known as Neo-Darwinism, is based on the idea that randomly occurring mutations in genes provide the raw material needed for evolution to work.
The idea that mutations are considered the engines of evolution has only one problem: there's no evidence to support it.
So if you think about changes in the genetic code, can you think of any changes that would be beneficial or helpful to organisms?
Almost all mutations are deleterious. Almost all of them do the organism absolutely no good. In fact, we have a devilishly hard time finding any mutations that do the organism any good whatsoever.
These organisms only really survive in the laboratory. No other fruit fly will mate with them. These are not promising avenues for macroevolution. They're in fact dead ends for evolution because these mutations cannot be passed on by ordinary reproduction. It's almost as if the fruit fly says, if you want me to exist at all, I better have 2 eyes, 6 legs, 2 wings, and so on. I better have more or less the normal form.
Modern Darwinists contend that there are some cases where mutations do promote evolution. Their chief example could be considered another icon of evolution: antibiotic-resistant bacteria.
Antibiotic resistance, in terms of natural selection, is an excellent example. And its use, I mean, it's one of the hallmark examples given in microevolution for support of Darwinian thought. However, I think in the last few years, it's got to be reinterpreted to a degree.
Laboratory research shows that when an antibiotic is applied to literally billions of bacteria cells in a petri dish, a few mutated cells that happen to be resistant to that drug remain. Those few cells can then give rise to a colony of resistant bacteria. The question is, how well does this mutant strain survive in the long run? This can be measured in what scientists call fitness cost. How well does this mutant bacteria survive when the drug is removed and it now must compete with the original parent bacteria?
These organisms are not able to grow with the fidelity, the robustness that the original parent did, and that's one of the things that we've been looking at. So you can take a culture of cells that are sensitive to the drug, plate them out on petri dishes that have the drug, but there's a single colony coming up that's resistant to the drug. One cell that gave rise to this colony was resistant to the drug out of 4 billion. If this is the parental strain, we now have a mutant, we grow them up separately, and then we put them in the same test tube without the drug. So now we've removed selection, and we can measure empirically the fitness cost in terms of how well the resistant organism can now compete with its parent.
The surprising result is that in a relatively short period of time, the resistant bacteria lose out in their competition with the parent. They can't reproduce as fast, and over a short time disappear.
Within 1 or 2 transfers of overnights, you can lose that population of resistant cells, and then after the 3rd transfer, the resistant isolate has been completely outcompeted by the parent. It turns out that the resistant strain has a defect in its information processing system. The cell's crippled, and there's a limit to how much change can occur. When the resistant strain comes into contact with a parental wild type in nature, the parental wild type will reestablish dominance in the population, resulting in no net evolutionary change. We're going backwards in terms of the fitness of these organisms, not forwards, is used as an example of evolution.